In this video, we examine the method of solving force and dynamics problems, in which the forces are arbitrary, and also the angle between them is arbitrary. We give example. Please pay attention to example. Please subscribe us to be informed about our new videos. Please see the video to the end to understand all its concepts. In part 25, we examined parallel forces. In part 26 we examined the perpendicular forces. In this part, we examine two arbitrary forces. This video is important, because it examines two arbitrary forces, whose angles are arbitrary. Tip: suppose two arbitrary forces, F1 and F2, are applied to a body. The angle between these two forces is theta. The resultant of two forces is calculated by the following formula. We have already mentioned the method of drawing the resultant force. Here we will remind again. To draw the resultant vector, we first put the vectors one after the other. The resultant vector is the vector that is drawn from the beginning of the first vector to the end of the second vector. If we want to calculate the exact value of the resultant vector, we use the following formula. Note that the right-hand side of the formula is equal to the square of the first force, plus the square of the second force, plus twice the product of the first force, multiplied by the second force, multiplied by the cosine of the angle between the two vectors. Note: in this formula, the magnitude of force is important, and we do not pay attention to the direction of the force. Sometimes, in order to indicate a vector quantity, a vector symbol is placed on it. Because, as we said before, the vector has two properties, magnitude and direction. But if we want to show only the magnitude or size of the vector, we do not put a vector symbol on it. Sometimes some people use the absolute value. In this formula, only the magnitude of the vector is important.
Example: suppose two forces, 4 newtons and 6 newtons, enter an object with a mass of 4 kilograms, as shown. Calculate the acceleration of the object. Answer: we can show the direction of the resultant force without calculation. There are several methods. We use the simplest method. That is, we put the vectors one after the other. We denote the result vector by F. We put the magnitude of the forces in the formula. Pay attention to the calculations. So the resultant force is 9.66 newtons. Now, let's use Newton's second law. Acceleration is 2.4 meters per second.
In this part, we explained how to calculate and draw the resultant force. In the next part, we examine one of the most ambiguous forces, the force of friction. Please look at the next part.